Go ahead and get started. This is Christine Bowles with Wisconsin Space Grant Consortium. I am the Assistant Director, and I am also the Program Director for First Nations Launch. So I want to welcome everybody. I do want to let you know that we are recording this, and we will have it posted on our website under the First Nations Launch Tools and Tips page. And it will be located under the FNL resources. So at this time, I would like to introduce our guest speaker, which is Aaron Ashley. He is a system safety engineer from Raytheon Missile Systems, and we are pleased to have him with us. He also, if you're new and listening for the first time, he is an alumni of the program and competed in the First Nations Launch Rocket Workshop in 2019. Aaron, am I correct?
18.
Wow, time is just passing by so quickly. So I want to welcome Aaron, and I'm going to go ahead and let him proceed and start the program.
All right. Yeah, thanks, Christine. So I'm going to, can you guys all see my screen? I'll take that as a yes. So I'm dividing this up into two sections, hopefully point out some ways we fail as rocket builders in avionics, and some switch types, as that's come up a lot in the virtual presentations. And then with RockSim and Open Rocket, similar thing. I just want to point out ways that we sometimes make errors in it and suggestions for improvement. And then I'll go through an example. So for avionics, electronics, or this is the avionics that are not part of your payload. So just the altimeter and deployment electronics, things like that. A common one I've seen a lot is the switch failure. So if you have a, say like a rotary switch or something bought off of Apogee for $4 or something, $7, I forget what the price is, but then you go install it in your rocket and come launch day, it fails, so you can't turn on your rocket electronics. That causes some, you have to come up with a backup plan for that. And in the next few slides, I'll go over different types of switches I've seen used and other ones you can use. Another one is your altimeter. Some of you guys are using stratologgers or featherweights or RC3s, and just not knowing how to program them or operate them, come to the launch site, or if you're at launch day and this is the first time you're opening up the altimeter and then you don't know how to work it and you hastily try to put it in the rocket, that's something else we've had happen before. And if you guys need help with that and don't understand the instructions, Mark, Frank, or me can set up a one-on-one call with you and go through how to program whichever altimeter you use. I wasn't planning on going into detail here, but if you guys want more information on that, you can ask toward the end. Another one is shoddy wiring, just putting together the wiring inside the electronics, and like the stratologger has those screw down, you put the wire in, screw it down so it stays in. If you put the wrong gauge, like a too large or too small a diameter wire, sometimes the contact won't be positive and it won't work. Or if you have too many frays and and you put those like right next to each other on the circuit board. I don't have one to show you, unfortunately, but and then the connections get crossed. That can lead to non-functioning circuit. So those are some things to keep in mind. And then testing your altimeter beforehand. That's not always possible, but it's a good thing to try and do, because we've had defective altimeters on some teams have had defective ones, and I mean sometimes it's for we just don't know how to program them, but sometimes it's an older one, or you guys' team had a predecessor 2 years ago who used it and you're reusing it, and it was broken during that year, but that information wasn't passed down, and you just say like, oh, we have this strata logger left over, and then you put it in and then it ends up not working. That's another way this is caused. So some altimeters have the instructions just to test it on its own, or the way we like to see, we don't require it obviously because not everyone can do it, but it's using a vacuum chamber or some way to mimic the altimeter actually going up in altitude and the air pressure going down, so the actual sensor, the barometric sensor, is tested. So that's that one. And then some other hardware failures, like your rockets are going very, very fast, which will be exciting to see, but some other things that can cause are if you don't put your 9-volt battery or whatever battery is powering your electronics, if you say just put a zip tie around it but nothing on the bottom, and say the G-force of the rocket just causes the battery to pull out the bottom or become disconnected in some way, or there's something tied to a weight or something shifts in there, the G-force upon launch can sometimes mess that up, and the only way you'd know that is during launch your parachutes don't deploy or your electronics don't work, and you really only find that out afterwards. So this is more, we have to do everything we can before launch to prepare for it and mitigate it beforehand. And another one, the altimeters measure altitude by the barometric sensor, which you guys probably know, but sometimes it's on the bottom. And if you screw the altimeter board to if you're using like a plywood plate or another kind of mounting surface, sometimes if you screw it right on to that surface, it will block that barometric sensor. So usually altimeters, I know that I think the strata logger comes with standoffs. Standoffs are just little plastic spacers that you put in between the altimeter and your mounting surface when you screw it down. So that just allows a little space around the barometric sensors to allow it to work. And then it'll have access to the air, and then with your vent holes, it'll have access to the outside atmosphere. So I'm going to go through some switch types, and then I'll open up for brief questions, and then we'll go on to RockSim and OpenRocket. So I just picked out some switch types that I've seen some teams use. Key switches, those actually have a physical key that go into it, and you mount it to the outside of your rocket. And so it's a physical key that you remove. And then screw switches, these have less moving parts, and they're fairly more reliable, but they're just basically a screw on your avionics board or your avionics surface that you mount, and you have to put a Phillips screwdriver through a vent hole to access it. So you have to line up your vent hole, and I believe you screw it in to arm the electronics. So that's something you don't do until the rocket is on the pad. And another one, rotary switch. This is one I've used before, and I personally had it fail. I'm not saying all of them fail, but this is another type of switch that you have mounted to the outside of the rocket. So you just mount it to the outside and then connect the wiring to your altimeter inside the altimeter bay or avionics bay, and then you put a regular conventional screwdriver in it to turn the switch on and off. And then they're generally made of a little cheaper plastic, so I think that's why it failed on me when I was on a team in 2018. So I ended up having to go through one on the next slide. But before that, magnetic switch. I haven't used these, but I've seen them on a switch list, so I just wanted to include it for completeness. But I believe, I actually don't know how these work. If someone wants to chime in after and let everyone know, I'd appreciate that. And then one other I wanted to go over, this is, if you have a switch that fails, or you can plan this beforehand, it's twist and tape. That's just basically you take your two wires that you would have previously used for a switch and you thread them out your vent hole so that you can access them on the outside. You put your rocket on the pad, and then you take those two wires, twist them together, electrical or masking tape them, and then stuff it back through the vent hole. And then that's a fairly reliable but low-tech way to arm your electronics. And generally when you do that, when you're on your prep table at the launch range, you would tape your two different wires to the rocket body so they don't touch while you're carrying it to the pad. So I wanted to open up briefly to questions about avionics before we go on to simulations.
And Aaron, I do want to just highlight, we have teams that are on from both First Nations launch, but I do see that we have a couple of folks on from our collegiate rocket launch within the state. So for those joining us from the state program, there's still great questions you guys can ask, and our team will be able to assist. We also have Frank on the line and Mark on the line. So they're all here to help everyone.
Sounds good.
Anyone have any questions?
Frank, are you able to highlight any of the types of avionics switches that Aaron asked for additional information or, yeah, on?
The switches are fine that he presented. The only thing we don't encourage is the stuff wires back through the hole. I mean, we do the twist and tape, and it's up to the flyer if they want to tuck them back in the hole. It's just in case if we abort a launch, or if the flyer forgot to put his parachute in the rocket and we're about to launch it, there's a hard time of trying to turn the electronics off. So we don't encourage the stuff back in through for new flyers or not frequently flyers. Usually we twist tape and we tape it to the side of the airframe, so it's exposed. So if you got to turn off the electronics, you can just untwist the wires and go on your merry way. That's all I got.
Thanks for the clarification. Yeah, just keep the wires on the outside. Don't stuff them in. Well, I'll let you guys continue to think. For now, I'll go on to the RockSim simulations. So from things that can go wrong, when we make our rocket simulations, we're using a 6-foot or 10-foot launch rail, and OpenRocket and RockSim both default to, I believe, 3 feet. So if you just use it right out of the box, you'll already be incorrect with the rail guide length, and that'll affect your let's see, what's it called, the off the pad your rail exit velocity, and that's something that we check in First Nations launch. It needs to be at least, I believe, 52 feet per second, if I remember right, and that's just to make sure it's going fast enough to be stable coming off the launch rod. But if you don't have the rail guide length correct in your simulation program, you won't know that's a problem, or it won't correctly reflect it. The other one is map. I guess I could show the rail length guide. I have OpenRocket open. I'm going to focus on that. So when you're going into a simulation and you have your launch conditions, for OpenRocket, it's launch rod down here. I have it on 72 inches because for this rocket, this is what my team used 2 years ago. Was using a 6-foot rail. And then on RockSim, it would be under your, it's not that, you prepare it for flight. And you have all these tabs across the top. It would be your starting state. You would put 72 inches up here for your launch guide length. And next one I wanted to highlight were mass overrides. That's a function of both OpenRocket and RockSim that they have RockSim, for example, has a database of different components. So if you want to look up your parachute that you bought commercially, you could find it in their database. But say, I don't know, you weight it before launch, and the weight that is calculated in RockSim does not match up with the weight that you measured on your scale. That mass override is a way to correct that, but the downside about those is it no longer, the RockSim or OpenRocket no longer auto updates the mass if you were to change it. So if you were to enable mass override for your parachute and then later go on to, say, decrease the size of your parachute to get your time down or weight down, or I don't know, some other parameter to change, if your mass override is on, it'll still have the old mass. So that's a downside of mass overrides. So that's always just something good to check that you know is on or off. And so, for example, this is OpenRocket. So if I go to my main parachute, edit that, you can set the third tab at the top here, override. You can override the mass to say I weighed it and it's 300 grams, not the calculated 214 grams. So if I do that, that's what the program will show. And you can see down here in this corner, overridden to 300 grams. And then in RockSim, go to your components table, find your parachute, edit it, and then it's also the third tab called Mass Override. And it's also a box that you check. And it'll have a note right here. I don't know if you guys can see my mouse, but it says Notes, Mass Override is on. So that's something you can check, and now that you guys are aware, or if you weren't before, you'll know it's there and you can check that. So I'm going to uncheck that box for now. And the next one, parachute deployment, also called flight events. If those are not configured correctly, it won't be a proper representation of your launch. So that could affect your altitude, or say your parachute was set to deploy a fixed time after launch, and you're, say, 8 seconds, and your time to apogee is 12 seconds. So this is just a made-up example. In your simulation, you would basically be saying your parachute is deploying on the way up, and which could happen, but that's generally not what we plan for. So that would artificially bring down your simulated altitude because of that, because it'll take into account the parachute is out while it's still going up. And where to access that, I'll start with OpenRocket again. So when you go to set up your flight simulations, when you prepare it, apologize, it's not there. I believe in OpenRocket, it's in your parachute. Oh, here we go. Deploys at, I'm looking at the right side. Deploys at specific altitude. This is my main chute, so I have it deploying at a specific altitude. And this, or 300 feet, or whatever you want, but say it was 8 seconds after launch and you didn't know that, you would know how to change it here. Or generally, if you're first making one from scratch and haven't, or you just downloaded an OpenRocket file from a manufacturer of a kit, I would generally first start with deploy at apogee for the drogue, and then deploy at a specific altitude for the main. And as you define the model further, you can tweak that further. And then in RockSim, I don't believe it's in here. For RockSim, I do believe you actually have to go to prepare. You can either go simulation, prepare for launch, or this little icon. It's the rocket with the smoke coming out the bottom, not the flames coming out of the bottom. That's prepare for launch. And then you go to flight events, the second tab from the left, and you have 2 events. So if you main shoot, you could set it to deploy at all these options, but main is usually deploy at an altitude. So you deploy at whatever feet, 300 or 500 feet. And then your drogue parachute, it's generally not this. If you get a off-the-shelf motor, usually the max ejection delay is like 14 seconds or something, and that's usually a little too late. So apogee, I usually set it to that, and that's what your electronics will, if you use dual deployment electronics, that's when this will deploy. Okay, so I'm going to move on to the next one, and that's just not accounting for all these things, all of the different weighting components you use. So say like you have this this is my level 1 rocket, but like you use these eye bolts. You could add that as a separate mass object, or even your shock cord. That's something you need to add as a mass component. And just things like that, or your rail buttons, or yeah, like your rail buttons, like this. I'm sure you guys have seen rail buttons before. Just things like that. Not adding them will not be a correct reflection of your rocket and can affect it on launch day. For rail buttons specifically, it's generally good to actually put the rail button on the side of the rocket. So I can't remember if I put mine in here or not, but what you would do is, yeah, it looks like I didn't do it. That's something I learned after I did this rocket. But you would add it, let's go add a component. You would add your rail button. Can't remember if it's a random mass object. I think we'd go it because it's on the outside. You want to account for the aerodynamic effects of it on one side. So you would add a rail button as kind of like a little fin that's sticking out, but it's a single one. It's a very small one. Where this is going. Trying to see it there, and then straight up, so we'll go 0 sweep. And see it there. We'll do a little bigger so we can see it. So if you guys see that there on the outside, and we can change where this is located. So say if you put a rail button somewhere around here, I'm not saying you should probably put it further back, but that's good to have in your simulation, because it is a physical object on the outside of your rocket that will pull your rocket to one side or affect the flight. So that's generally good to include. And then surface finish, that's something more like if you expect your to be painted, like painted and sanded, or if you're just going to be launching it as is with no surface preparation, that'll affect the drag a tiny bit. But if you're aiming for an altitude, it's generally good to have that as accurate as you can. And full screen. And then the last one, it's just the way you approach these simulations. We just have to understand that they have error in them. They're made on behind the program. They make these discrete representations so they can run it through a computer algorithms to calculate all these values, and they'll have a margin of error in them as best as we try to represent them. So you just have to keep that in mind. And then I think I just had one more slide that, another point I wanted to make was Open Rocket versus RockSim. We generally talk about RockSim in First Nations launch, but of course Open Rocket is always out there, and I believe some of you are already using it, but if everyone during the remote working and everyone will be in different places, it's easier to have multiple licenses of Open Rocket, which is free. Well, it's not really a license, but everyone can download it, versus some of you only have one license for your school, or I know we did at my CU Boulder. So if you stuck with RockSim, that would mean only one person could work on it. So Open Rocket is always an option. And then I just wanted to go back to the example and show you in-depth different things you could do. So like your nose cone, if you were to add it, you would, under this add new components, body components and fin sets, and then click the nose cone button. And then I had added a mass object here, and that's, you would just add the, it's called a mass components, and that's just something that you can specify a weight if you need to change your center of gravity or center of pressure, and just make sure it's not over 10% of your total weight for the First Nations launch requirements. And then, so the hierarchy, I have a main chute tube. I'll just collapse all these to show you all what I have. So nose cone, the main chute tube, that's the top one where I put all the main parachute, and I believe that's what owns the avionics bay as well. So if I add a component, I would make sure to highlight that one and then add that. And then the lower body tube would have all the fins and the drogue parachute and shock cord and the motor, your motor retainer, just the bottom part. You would add, like, if you have a motor retainer, you would add that down there. Yeah, so I'll just expand those again. And when you go to add your avionics bay, you can be as specific as you want. I think here I added an object for my straddle locker, and it was it looks like just a mass object. So that's something you can add if you mount it slightly to the side and not directly in the middle of the board. You can go to radial position and then give it a, say it's 1 inch from the center, radial distance outward. So that's something else you can do. And I had a battery, these caps were just bulkheads. They just like these plywood bulkheads on either side of the altimeter bay. And then these were like quick links. Actually, no, not quick links. These were the eye bolts. The eye bolts, I had located them at either end of the avionics bay. And those, I believe, were mass objects as well. And you can specify what it is just for your own knowledge. I don't believe that affects the actual simulation. It just gives you a nice little icon on the left bar. And same thing for shock cord. I believe that there is actually a shock cord component you can add when you go to add a new component, and it'll calculate the weight of that for you. Or if you weigh it afterwards and find it's different, then you can mass override it. Just don't forget if you're overridden the mass. And yeah, bulkheads, more hardware to unspecified on that one. I think I was going for like the screws and other wiring. And then if you have more tube, this is just a little slit of tube I put on the outside where I drilled my vent holes. I just added that as a separate tube here. And then if you use a kit, it'll already have your motor mounts and fins, but you can still specify things like your finish, if you're painting it, if you're lowering if you're sanding it to an airfoil or sanding it to rounded. That's just like sanding the edges to make a rounded edge at the top here, or an airfoil from like thicker up here and thinner down here. That's what that would be. And then centering rings for your motor mounts. Just make sure those are where you actually want them to be. And let's see, attachment hardware. This was just an eye bolt I put on one of my motor mount centering rings to mount my shock cord. So that was just a mass object, recovery hardware. And then another shock cord. I added paint mass. I just applied that at the center of gravity, just to account for just the weight of the paint. And I think that's all I had to cover. Frank or Mark, if you wanted to make any of the other points, feel free to join in. And if not, we can open it up to questions.
I would say, why don't we go to questions? Does anybody who's listening on have any questions? Comments?
You know, one thing I didn't do was go through an actual simulation. So let's do that real quick. So you would go to your simulations tab, and you would have already added a motor back on your motor mounts. You would have chosen one. Let's see. Not there, but when you do your simulation, oh, here, you choose your motor here. So if it's no motors, and then you choose one. And then so for this one, I had 20-mile-an-hour wind. That's obviously more than we would launch with, but that's just seeing what would happen then. 6-foot launch rail. You generally don't need to change the longitude, latitude, and site altitude unless you really wanted to. And then we generally don't change simulator options. That's the behind the computer stuff. Is the actual algorithm that calculates everything. And then when we go to simulate and plot, you can choose what you want to show. I'll just keep what it has here. And then go ahead and go plot, and it'll run the simulation. This one usually takes a few seconds because it is calculating at each time step. And then an open rocket on the far upper left side, you see the red circles. That just means that simulation is out of date. Like since you run it, you've changed a mass or you've changed a component. So when we rerun this, that red dot will become green, just showing that it's up to date. There we go. So this is a plot that it gives, so you can take a screenshot of it or zoom in or zoom back out. And then data points on and off. And then you can also export the data if you want to bring it into Excel. You can select your variables there that you want to see, and then it'll export a CSV file. Not yet. but as you can see, it's green. So it's just something to point out. And you can customize these columns as well, I believe, or sort from them. And then if you want to quickly rerun them, you can just click on one that's red and click Run Simulation, and that'll just run it again without plotting anything. So if I just run all these, that'll just make them all up to date. Just like that. Anyone come up with more questions during that time?
Well, on behalf of Wisconsin Space Grant and the First Nations Launch Program, Aaron, I do thank you for giving this presentation. If anybody does have questions, you can feel free to send a note to myself, to Frank, to Aaron, any of us. We would be happy to answer any of those questions. We know for many of you, rockets are a little bit on hold as we are all in our own homes right now, but we hope that you're still learning, and if you have your rocket with you, that you're able to continue building during this time. Are there any other comments from Frank or Mark? I see Orson, you're on as well. Or Aaron, anybody else before we sign off?
This is Frank. I just want to encourage the teams out there to make sure that don't let your guard down. Don't if you get something to do, let's try and attempt to collaborate with the team either by virtual or somehow, and try and get your rocket somewhat constructed in a way where you can be prepared when it's time for launch time. That would be grateful, appreciated. Thanks.
Thank you, Frank. Anyone else? Again, thank you, Aaron, very much. We greatly appreciate the time that you spent putting this together and presenting to us, and wish everybody else to have a very safe and good afternoon and rest of week.
Yeah, thank you all for attending.
Thank you.